Good day, I am Daphne in ID 124, and I will be teaching Foundational Mathematics LQ3 with the topics of sine, cosine, and tangent graphs. So let's start by graphing our y equals to sine x and y equals to cos x. So given the values of pi over 2, pi, 3 pi over 2, and 2 over pi, let's substitute x with these values, and by substituting these values, we have a value of 0, 1, 0, -1, and 0. So as you can see, you might notice a pattern in your y-axis that we're going to start with our 0, followed by a 1, and then after that 1, we have a 0 again, and then after that 0, we have a 1, but it's negative, and then 0. So there's a certain pattern for this. And we know that in a sine graph, we would always start with our y is equals to 0. This is for the positive side of our plane. In our cos x graph, while we substitute x with these values, we have our y is equals to 1, 0, -1, 0, and 1. So that means there's also a pattern in our cos x graph, except that we start with our y is equals to 1. So in our sine x and cos x graph, we have this red segment called the period. And the formula for a period is equals to 2 pi over b. Where, based in our standard form, which is y equals to a sine b x minus c plus d, which I will be further discussing later, we know that our b is equals to 1. And 2 pi divided by 1 is equals to 2 pi. And we can get the 2 pi from here. So this will be our period. And when it comes to our sine graph, and when it comes to the period of our sine graph, we start our y with 0, and we end our y with 0. In our cosine, we apply the same formula for our period, which is 2 pi over b. And we know that our period would be equal to 2 pi divided by 1, which would be equal to 2 pi. And again, the 2 pi would be coming from here. So let's start with our A, or amplitude. So what if we are given different values of A? So let's say that our A is equals to 1 here, and our A is equals to 3 here. And by graphing that, we know that our sine x, we always start with the origin here. And then the thing about our A is this, that this would be our minimum and maximum value of our y-axis. So pi over 2, it's going to be 1, and then 0, then -1, and then 0. While for our 3 times sine x, let our maximum and minimum values of y be 3 and -3. So again, when it comes to the sine graph, we always start with the origin, and then we proceed to our maximum point, which is 3 here, and then we go back to 0, and then -3 here on 3 pi over 2 here, and then go back to 0 here. There we go. So what's different between a is equals to 1 and a equals to 3 is that 3 has a larger height compared to a is equals to 1. So next is our variable b, which determines the spreading of the graph. So an example here would be comparing cos 3x and cos x, wherein our b would be equal to 3 and 1. So let's start with b equals to 1. So for our cos 1x, we know that our b equals to 1, and we know that the formula for our period would be equals to 2 pi over b. And our k, therefore, would be equal to 2 pi. And we know that when we graph our cosine of x with one period, it would look something like this. So, and based on y equals to cos 1x here, we know that our amplitude is blank, so our amplitude is equals to 1. So we're going to start with 1, and then 0, 0, then -1, then 0 to 1 again. So this basically completes one period. And our one period here would be from 0, x equals to 0, to x equals to 2 pi. And we know that k is equals to 2 pi. And then this goes on. And then we have our y is equals to cos 3 of x, where our b is equals to 3. So with this, we're going to use our period formula, which is k is equal to 2 pi over b. So we substitute b with 3. So we have k is equals to 2 pi over 3. So our period would be placed somewhere. 2 pi over 3 is located here. And when we graph our cosine, again, our amplitude would be equal to 1. So we start from 1. And then we also end at 1. And remember, for one period in a cosine graph, it would look like this. So we can just trace accordingly. We have 1, 0, negative 1, 0. And then the rest just goes on. Oh, messy graph. But the period would start from x is equal to 0, which is here, to x is equal to 2 pi over 3, which would be our k, or our period. And as we compare y is equals to cos 3x and y equals to cos 1x, we might notice that y is equals to cos x is wider compared to y is equals to cos 3x. So for our c variable, we have left and right shifts. So I gave out two equations for this, which is 3 sine x plus 1 and 3 sine x minus 1. So let's start with the right equation. So for example, we have 3 sine x minus 1. And we know that our amplitude is 3. So when we graph a sine graph, again, we start from the origin. Then positive 3, 0, negative 3, 0, and then so on. And the same goes for the left graph. Kasi same naman sila amplitude, which is a is equals to 3. But what we know about the right equation is that c is equals to 1 based on our standard form. We have x minus c. So if c is equals to 1, then we'd have to shift our graph by 1 unit to the right. So we would move 1 unit to the right. So let's start from, this is the origin. So it's here. So we're shifting our graph to the right, and we have x equals to 1 here. And since this equation is continuous, then we would have to draw the others. So this would be your graph to the equation. But in our left equation, we have x plus 1. And since we encountered x plus 1, then our c would be negative 1. That means we have to shift our graph to the left. So we shift our graph 1 block to the left. So then we have our x is equals to negative 1. And then the entire graph just completely shifts to the left. And lastly, for our variable d, it focuses on the up and down shifts. So let's say we're given two equations again with different values of d. So let's start by graphing 3 sine x first. So we have this as our graph. And for this first equation, we know that our d is equals to 2. And since our d is equals to 2, we have to shift the graph up 2 times. So here it's going to look like this. While for our second equation, y is equals to 3 sine x minus 2, we know that our d is equals to negative 2. And since d is negative, we would have to shift our graph 2 times. So it would look like this. So when it comes to graphing sine and cos graphs, you might be asked to find your A, B, C, K, and D, as well as your intervals, your domain and range, and your starting point. So we're given an equation of y is equals to 4 sine 2 x plus 3 minus 2. And using the standard form, which is a sine b x minus c plus d, we can just plug and play. So we know that our a is equals to 4, our b is equals to 2, our c is equals to negative 3, and our d is equals to negative 2. So how would we graph this? So let's start by making a plane. So this will be our plane, and we let our x values be our bases, which is pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. And the first step here is to find our value of k. So k is equals to 2 pi over b. And we know that our b is equals to 2, then our k would be equal to pi. So our period would start from here to here. And we know that one period of a sine graph would look like this. So we know that our maximum point would be 4, and our minimum point would be, our minimum y value would be 4, and our minimum y value would be negative 4. So we'll just graph accordingly. So we know that our a is equals to 4. And then we'll just, there we go. Now that we've checked our A and B, now let's check our C and D, which we know that C is equal to negative 3, and by looking at C, we would either shift to the left or to the right. But since our C is equal to negative 3, then we would have to shift our graph to the left 3 times. So let's say 0, 1, 2, 3, somewhere here. So then your x would be negative 3. Now that C is done, let's look for D, which our D would be equal to negative 2. And what we know about D is that we can either shift up or down. And since D is equal to negative 2, then we have to shift the graph down 2 times. So we have shift down. Your graph would look like this. And knowing that our graph for this equation is continuous, we can say that our domain would be infinity, negative infinity to infinity. While our range, we can see that our minimum and maximum values of y have changed because our d is equal to negative 2 and we shift our graph down. So our range would be from positive 2, because since this is the highest point, positive 2 maximum value, and your minimum value would be negative 6. So your range would be from negative 6 to negative 2. I actually forgot to put the brackets because negative 6 and 2 are included in the graph. So this would be your final answer. So next we are given this graph of negative 3 cos 2x minus 8 plus 1 half, and we needed to find a, b, c, k, and d, as well as the interval and starting point. So based on the standard form, we know that our a would be equal to negative 3, and our d would be equal to positive 1 half. For b and c, a common mistake that most students do is that they let their b be 2 and let their c be positive 8. This is actually wrong because based on the standard form, we know that x should be alone and the constant should be outside the parenthesis. So what we would do here is to factor out our 2. So we would get 2 times x minus 4. So that's where we can say that our B would be equal to 2 and our C would be equal to 4. So when we graph this, A is -3 pala, my bad. So when we graph a cosine graph, then we would start from the amplitude, or our A, which is -3. So we're going to start from -3 here. But we're not going to trace anything yet because we're going to find our K value given our B. So our K, our period, would be equal to 2 pi over B. And we know that K is equal to 2 pi over 2. So therefore our K would be equal to pi. So our period would be, in the x-axis, we would start from 0 to pi. And we know when we graph a cosine, we would start with the amplitude. So from 3 until here, 3 to +3, there. So this would what your graph look like in one period. And it's ranging from x equals to 0 to x equals to pi. So we'll just... Alright, so once that's done, we've found our A. We've already graphed our A and we've already graphed our B. So now let's graph our C and D. So we know that in C, it's either we shift to the left or to the right. But knowing that our C is equals to +4, then we would have to shift our graph to the right 4 times. So
Move this whole thing yellow to the right 4 times, so it probably be here.
somewhere here. And since the graph is continuous, then we should continue filling the rest out.
So
here, initially, this one is x equals 0, but now it's x equals 4. So we're done with C. Now for D, all we have to do is to either shift your graph up or shift your graph down. And since D is equals to 1/2, +1/2, then we have to move our graph up. So we have to move the whole thing up. It would look like this. There we go. So this would be your final graph. Since now that's done, we know that our domain would be equal to -infinity to +infinity. For our range, initially we have 3 and -3 as our minimum and maximum value, but since we move 1/2, since we move the graph up by 1/2, then we would have to add 1/2 on both 3 and -3. So this would be equal to 3 and 1/2 and 2 and 1/2. So therefore, our range would be equal to from 2.5 or 2 to 1/2 to 3.5 or 3 and 1/2. So this would be your final answer. We have your domain, range. These are basically the intervals. Next is that we have y is equals to -3 sine 2 pi x plus 2 pi over 3 plus 4. So the first thing we would have to do is to find our A, B, C, and D. So for our A, we know that A is equals to -3. And our D would be equal to +4. But for our B and C, we have to make sure that x should be alone in this parenthesis. So we have to factor out our 2 pi. So by factoring out 2 pi, we get x plus 1/3. So therefore, our B and C would be equal to 2 pi, and our C would be equal to -1/3. And we know that when we have our sine graph, we would start with our origin. This would be our starting point. But again, we're not going to trace anything yet because we have to find our period, or k. So we know that our k is equals to 2 pi over b. And we know that our b is equals to 2 pi, so k would be equal to 2 pi over 2 pi, which is equals to 1. So from this point to this point, we would have our sine graph. And we would start with -3. So -3. So for the sine graph in one period, we would start from 0 to our amplitude, which is -3, then 0, then +3 to 0 again. So for the period, we would start from x equals to 0 to x equals to 0 again. So you would need to trace this again. So we have, now that we've graphed our amplitude and period, now we would have to observe our variable c, and our variable d. So we know that c is equal to -1/3, and in the c variable, it's either we shift to the left or to the right. But since c is -1/3, then we would have to shift our graph to the left by 1/3. So here, 1/3. Guessing it would look like this, and then we know that our x here would be equal to -1/3. Now for our d, we know that d is equal to +4, and since it's +4, then we would have to shift our graph upward. So our graph therefore would look like this. Oh, that's too high. So now that our d is done, we can finally find the interval of this graph. So we know that this graph is continuous, so our domain would be +infinity, actually -infinity to +infinity. While for our range, we can see that our minimum value for y would be +1 after we shift our graph upward. So we would start from -1, from +1 to the maximum value of y would be 7. So from 1 to 7. So this would be your final answers now. Before I end this, I would like to briefly discuss about the graph for tangent x. So as you can see here, that when we plug in our values of x, we have a pattern of 0, undefined, 0, undefined, and 0. So the only zeros that we have, the only y equals to zeros we have are pi, 0, and pi, followed by another pi, and then another pi, and then so on. And then we also have undefined values. So after y is equals to 0, there's a case where it goes up infinitely. So this is why, let's say from pi to 3 pi over 2, it becomes undefined. So there's actually a pattern for this. While for the green graph, we can see that y is equal to -tan x, or y is equal to tan -x would give you the same graph of y equals to tan x, but opposite. So instead of, let's say for instance, let's start from 0. So if you want to go from 0 to pi over 2, then we would move down. We would infinitely move down. And the same goes for from pi to 3 pi over 2. And we can say that our range would be equal to -infinity to infinity because there's no maximum and minimum value for the graph. And for our domain, we can say that the domain is all real numbers except for the asymptotes, which include 3 pi over 2, pi over 2, -pi over 2, and -3 pi over 2. But since y equals to tangent x is a continuous function, there are many more asymptotes. Actually, there are an infinite number of asymptotes to this equation. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on the screen. Once again, this is Daphne from Syntax, paving your way to excellence.